Good day, grade 11s. Today we are going to look at special angles. You have done special angles in grade 10. They come out of, the special angles give us ratios that come out of these two triangles. We've got an isosceles triangle, which has sides 1, 1, and then by Pythagoras, you get that this is root 2. And then because it's an isosceles triangle, this is 90, and then this will be 45, 45. Okay, and then you've got this other triangle, which was an equilateral triangle, meaning that this side was 2, and the other side that goes this way is 2, and then also the other one is 2. So if it is an equilateral triangle, it will be 60, 60, 60. Then we divide it in half and only just concentrate on the one half of the triangle, which is what I have drawn here. But that was introduced in grade 10, so that's why I didn't draw the complete triangle here. So these are the dimensions that we have: 1, 2, and then by Pythagoras we find that this is root 3. So the special angles, that whenever we're talking about special angles, we're talking about these angles 30, 45, and 60. So these special angles give us trig ratios that will allow us to work without the calculator. So sine 45, from this sine 45, if I stand here, sine is opposite over hypotenuse, so it's going to be 1 over root 2. So it is important that you know these triangles, these two triangles, because that's what you're going to make use of when you have to use special angles. Okay, so these are the ratios that we get for 45, and these are the ratios that we get for 30. Now it is important that you master this, because if you punch this in your calculator, you'll see that it will give you root 2 over 2. And now this shows that you have used a calculator, and yet if you have used the diagram, your answer will be 1 over root 2. So you have to be careful, because if we find that you have written root 2 over 2, then we will see that you have worked with the calculator, and yet the instruction was without the calculator. So you have to be careful there. Okay, so that means that if as you can see, if you remember from the exercise from yesterday, there was an answer that was cos 60. So that means we cannot just leave our answer now as cos 60, because as you can see, cos 60 is a special angle. So it means that we are going to then go further from cos 60 and then write our answer as what? As a half, using the special angles. Okay, so we also include 0, 90, 180, 270, and 360 as part of our special angles. But we don't have a we do have a diagram that you can use for this, but these ones, because they just give you 0 and 1, you can just try to remember them. They are not like those ones where you have to use the diagram. Okay, so let's look at an example of how or when to use these special angles. I've got cos 180 times sine 225 times cos 80 all over sine 170 times tan 135. Okay, so now as you can see, we've got 225, we've got 80, which is an acute angle, so this one doesn't need reduction. So whenever there's an angle that is more than 90 degrees or less than 0, you have to reduce that one by the laws that we have established on previous lessons. So we are going to reduce this 225. It is on the third quadrant. On the third quadrant, sine is negative. Okay, and then how do I get this value that it is going to become? Please, I make use of this, because I can see some people are messing it up. Remember that we've got our 4 quadrants. The 4 quadrants are like this. So we've got our theta here, quadrant 1, and we've got quadrant 2 here, which is when we calculate angles here, it is 180 minus theta. And then quadrant 3, the angles there we calculate by 180 plus theta. And then quadrant 4, we calculate the angles there by 360 minus theta. So whenever you are trying to reduce, this is what you must make use of. Okay, so 225 is on quadrant 3. Quadrant 3, the angles there are 180 minus theta. Then from there you solve for theta. So if I take 180 to the other side, theta becomes 45. So that is what I have over there. Okay, this one is not a special angle. I cannot reduce it, so I just leave it like this for now. Okay, and then 170 is on the second quadrant. Okay, so second quadrant at 180 minus theta. Again, you solve for theta. So theta comes this side, 170 on the other side. Theta becomes 10. Then you've got sine 10 degrees. Okay, and then you have tan 45. Again, 135 is on the second quadrant. So you solve for theta from 135 is equals to 180 minus theta. It will give you 45. Okay, so since this is a special angle, we can find the fraction without the calculator. So it gives us negative 1 over root 2. Then cos 80, again it comes back as it is because it's not a special angle. And I can't use a calculator to punch in cos 80 because it says here without a calculator. Okay, sine 10, again I leave it like that. Okay, and then tan on the second quadrant, it's negative. That's why here we have negative tan 45, which then gives us negative 1. Now you see that this negative 1 will cancel with that negative 1, and then we have something like this. So the final answer would have been negative 1 over root 2 cos 80 over sine 80. Now if you look at this, 80 and 10, they give you 90 degrees. So and okay, I've written here 90. 80 is equals to 90 minus 10. So that means cos 80 is actually equals to sine 10. Remember we said earlier on, if I'm on the first quadrant here, I've got 90 minus theta. So 90 minus 10 gives me 80. So that means I can change cos to sine or sine to cos. So just remember that if those two add up to 90, when you compare them, if they add up to 90 and the other one says cos, the other one says sine, it means that the two are going to be equal based on, again, the relationship that we established earlier on. Okay, so I'll say that again. If this is 80 and this is 10, when you add this up, if it gives you 90, the one says cos, the one says sine, you can cancel out the two because they are actually the same. So then that leaves you with 1 over root 2, which then gives you negative root 2 over 2 after rationalizing. Okay, let's look at the next example. Okay, I'm going to again just go on this one. Sine 20 over cos 20. Let's say you've worked out and then this is what you have. Now if you look here, 20 and 70, when you add them up, they give you 90, and then this one is sine, this one is cos. It means that I can change this one and write it as that one, or change this one and write it as that one. So then I will be able to cancel, and then my answer will be 1. Now please note that if it is sine 20 over cos 20, I can't change, these two angles need to add up to 90 for me to be able to change the other one and write it in terms of the other one. Okay, so this one would give you tan 20 by identity number 1. Okay, so I've got another example here, which is an exam type of a question. Says show that 315 plus 1 cos 315 plus 1 over sine 315 minus 1 is equals to 1. Now remember, if a question says show that, it means you work with one side to show that it is equal to the other side. So we are going to work with this side. So again, you've got 315, 315. That tells you before you can do anything, you need to reduce this. So 315 is in the fourth quadrant. So fourth quadrant angles, they are 360 minus theta. There's no other way that you can run around this. You have to work it like this. Please don't use 270. It's going to confuse you. 270 and any other number. Just use 360 and then and the 180 for the other quadrants. Okay, so 360 minus theta, again you solve for theta, so theta becomes 45. So that means cos this one, because it is in the fourth quadrant, cos is positive in the fourth quadrant. So that's why here we've got cos 45. And then sine is negative in the fourth quadrant. So we are going to have negative sine 45 minus 1. And then cos 45 is 1 over root 2. Sine 45 is 1 over root 2. So minus, then you've got this fraction that you must now simplify. So I changed the 1 to root 2 over root 2 by doing the same denominator. Also here I did root 2 over root 2. And then to try and simplify this, I've got this fraction, this one. If I write under one denominator, because now the denominator is the same, divided by that, we change the sign and we reciprocate, and then it gives us that, which is still not 1. Now if you notice, I can factor out, you can factor out negative 1 at the bottom. If I factor out negative 1 at the bottom, when you factor out, this one becomes positive, this one becomes positive. Then now the top is the same as the bottom, so I can cancel out and remain with 1 over negative 1, which gives me negative 1. Okay, so sorry, here it's negative 1, not 1. Okay, so it gives you negative 1, which is equal to the right hand side. Okay, so I hope that is clear. Please do exercise 6, these questions, and then please on question 4 change the question to this instead of what is written there. Okay, and then again I'm going to wait for 3 responses before I can send the answers. Thank you.